All right, guys, today we're going to be solving systems of equations analytically. Solving systems means finding the value of all the variables that makes the system of equations true. And a system of equations is when there's more than one equation with more than one variable, and we need them all to be true at the same time. And analytically means using algebra steps. There's a really cool way to do it using a calculator if you have one, or a computer that is a lot faster if you have access to it. And we'll learn about something called a matrix next class that lets us do stuff with that. But for now, we will learn how to do, this is what you would do if you didn't have a computer or calculator. This is what you would do. So let's start with an Algebra 1 level system of equations. And go ahead and try this one on your own. Go ahead and solve this. And I hope you realize that the best thing to do here is, because we have what x, there's more than one way to solve it. You might have solved it a different way, but because we have what x is equal to, a lot of times what we like to do is we like to substitute what x is equal to into what y is, into the x in the other equation. And when we do that, so x is going to become 2y plus 3, and then everything else in the equation will stay the same. So 2y plus 3, that's what x was equal to, plus y equals 9, and x was 2y plus 3. And what this does is, instead of having two equations with two variables, when we do substitution variables, now we have one equation with one variable. And we can solve it using our basic Algebra 1 steps that we learned at the beginning of Algebra 1. So we can combine like terms, we can subtract 3 on both sides of the equation, get equals 6. We can divide by 3 on both sides, and we can get what y is equal to. Now that we know what y is equal to, we can take y and substitute it back in at the beginning to find what x is. So when I substitute this in, it'll still say x equals, but instead of 2y times 3, it'll be 2 times what y is, and y is 2. So 2 times 2 plus 3. So the y was 2. 2 times 2 is 4, plus 3 is 7. So x equals 7. And when there's two variables, sometimes we'll write it as a 0.7 comma 2, like this, where it's x comma y. Okay, so that's what we should know from Algebra 1. And again, I want to remind you that the way this substitution technique works is when you substitute what x is into the other equation, okay, now you've just got one equation, but it only has y's in it, not y's and x's. And then that's easier to solve. So we go from having two equations with two variables to one equation with one variable by doing substitution. We're going to use that same idea to solve Algebra 2 level systems of equations. Now, what makes Algebra 2 level systems of equations different is that instead of having just two variables with two equations, we're going to have at least 3 variables, sometimes more, with 3 equations. You need as many equations as you have variables. And so here, this is coming from your homework. There's variables x, y, and z, so that's 3 variables. And so we have 1, 2, 3 equations. So here's what we're going to do. We are going to use the same idea we used up above on Algebra 1 level equations, and we're going to use substitution. Sometimes you won't have what one of the variables is equal to, and you'll have to solve for it. We'll talk about that in a little while. But if you do have what one of the variables is equal to, we will use systems of we will substitute what that is. So which variable do we have solved for here? And hopefully you notice we have what y is equal to. It's called solved for. We know what y is equal to. Y is equal to x plus z. And what we are going to do is we're going to take whatever y is equal to, and everywhere in the other two equations where there is a y, we will put in what y is equal to, x plus z. So we will put in x plus z here, and we will put in x plus z here, and we will write 2 new equations. And what this is going to do, so I'm going to write x, but wherever there's a y, I'm going to substitute it. So x plus z, I'm going to substitute in what the y was, plus z equals 20. That's the first equation, right? And now that first equation doesn't have a y in it anymore. We substituted y with x plus z. Notice that there's just x's and z's. There's only 2 variables instead of 3. The second equation, we will also substitute, and so it said 5x, so we're going to leave 5x alone, plus 3, and we're going to multiply times y. Now, if there's a binomial, we wouldn't just put 3x plus z, we put 3 times x plus z in parentheses, because 3 was multiplying times the whole y, it needs to multiply times everything y is equal to, plus z equals 68. So notice that in equation 1, we substituted out y with x plus z, and in equation 2, we substituted y with x plus z. And now, both of them will have just x's and z's. So instead of having 3 equations with 3 variables, we now have 2 equations with 2 variables. What we will always do is we'll simplify these system of equations. After we plug in, we'll start by simplifying. We'll combine any like terms we can. So the x can combine with the x, the z can combine with the z, and it's still equal to 20. If there were any constants on this side, we could move it over to combine with the 20. Here we've got 5x. 5x plus the 3 is going to multiply. So 3 times x is 3x's. 5x's plus 3x's is 8x's. 3 is also going to multiply times the z. 3 times the z is 3z. And 3z plus z is 4z's. And that's still equal to 68. And now we have a system of equations with just 2 variables and 2 equations. This is now an Algebra 1 level equation. I want you to solve for x and z. What is x equal to and what is z equal to? And hopefully you were able to solve it. From here, I would use elimination. When the x's and the z's are lined up like this, I like to use elimination. And again, the way that works is we're gonna eliminate either the x's or the z's. I could eliminate the x's by multiplying this whole equation by -4, because then I'd get -8x's. I can eliminate the z's by multiplying by -2, because then I'll get -4z's, and those will be smaller numbers. So I'm going to multiply by -2, because I see that that will make the z's eliminate. -2 times 2x's is -4x's. -2 times 2z is -4z's. -2 times 20 is -40. And the way elimination works is once you have an opposite pair, you can add them together and we will eliminate the z's. -4x's plus 8x's is 4x's, or you can think of it as 8 minus 4. These will be 0z's when we add them together. Here, when we add these, we get 28. And now we have just one equation with one variable. So we can divide by 4, and we get x equals 7, okay? Once we have x, once we have one of the variables, we will plug back into an equation that has just x and another variable, so x and z. I can plug in x is 7 here and get 2 times 7, because we just found that x was 7. 2 times 7 plus 2z equals 20. And I can solve this one variable equation now. 14 plus 2z equals 20. I can move the 14 to the other side by subtracting 14 on both sides. 2z, 20 minus 14 is 6. Z equals, divide by 2, 3. So I've got x, I've got z, and I still need y. So I'm going to go back to the original problem where I had an x, a y, and a z, and I'm going to plug in x and z. And it doesn't matter which one of these equations. I'm going to look for whichever one looks easiest. Ooh, this one looks really easy. Y is x plus z. So I'm just going to put in y is x, which was 7. So y is 7 plus z, which is 3. And so y is 10. And this is the solution of the system of equations. X is 7, y is 10, and z is 3. If I plug in these 3 variables, it will make all 3 of the equations true. 7 plus 10 plus 3 is 20. 5 times 7 plus 3 times 10 plus 3 is 68. And 10 equals 7 plus 3. So for these values of these variables, both the equations are true. All right, let's look at this one. This is the first problem on the homework. And I just want to point out that this sometimes confuses kids because they say, okay, like what variable do we know? What variable is solved for? And the answer is y. But it's solved for in two different places. And it doesn't matter which one you choose. Whichever one you choose, you need to substitute it in both of the other places. But what you can't do is you can't take like this y, plug it into here, take this y, plug it into here. That won't work. You need to take one of the y's. So like I'm going to take this first y. Y is equal to 2x plus 3. And I'm going to put it into y in this equation. And I'm going to put it into y in this equation. That's the key idea here, is that you can only take one of the equations and plug it into both of the other ones. Even though there's two places where I know what y equals, I'm not plugging this y into anything. I'm taking this one y and putting it into both the others. Because what it's going to do is it's going to replace all the y's with x's so that there aren't any y's in the problems anymore. It's just x's and z's. So when we plug this in, we get 2x plus 3. I'm going to put this right over here. 2x plus 3, I substituted 2x plus 3 in for y, equals z minus 49. And in the second equation, I'm going to get x plus the y is 2x plus 3, so 2x plus 3 plus z equals 180. And notice, instead of having 3 equations with 3 variables, I now have 2 equations with only x's and z's. The next step is to do what? We need to simplify. And the only thing I can really simplify in this first equation is I have 2 constants. I'm going to move the, I think I'm going to move the 49 over to this side, although I could just as easily move the 3 over to the other side. But I'm going to combine my constants by adding the constants so that they can combine with the like terms. But since they're not on the same side of the equation, I need to add 49 to both sides to be able to move it. That's a legal move I can do. In this one, what is this going to simplify to? Well, I have x plus 2 x's, that's 3 x's. This 3 can combine with the 180, and I'm going to move the 3 to the other side because it's looking like this left side's already too crowded. The plus z doesn't combine with anything, so I'm going to leave it. Equals 177. And now I've got 2 simplified equations with just 2 variables, x's and z's. Go ahead and solve it from here. Solve for x, y, and z. You'll solve for x and z first here, and then once you have x and z, you'll go back to the original one and solve for y. All right, hopefully you chose an appropriate method. To me, it looks like this is a good one for substitution. Z equals this. So I'm going to put in 2x plus 52 in for z. You could have done elimination if you had moved z over to this side and 52 over to this side. You could have added the equations, but this sure seems like a good one for substitution because we know what z is equal to. So I'm putting in 2x plus 52 in for z, 3x plus z is 2x plus 52 equals 177. So the z became 2x plus 52, and now it's just one variable with one equation, just x's. I'm going to combine these. 2x plus 3x's is 5x's. I want to move the 52 to the other side by subtracting 52. And this is 125. And the last thing I can do is divide by 5. So I have figured out what one of the variables is. X is 25. That's part of the solution. Now I need to take x and find an equation that just has x and one other variable. I could plug in x here. I could plug in x here. This one looks pretty easy to me here. So 2 times 25 plus 52 equals z. 2 times 25 is 50. 50 plus 52 is 102. So z is 102. So I've got x and z. And now that I've found x and z, I can go ahead and find y. So y equals, guys, I could get it from this one or from this one. I don't have to use both. I know what x is. So I can plug in x is 25 here, 2 times what x is, plus 3, x is 25, so 2 times 25 is 50, and 50 plus 3 is 53. So y is 53. So x, y, and z. Last, this equation has 4 variables, a, b, c, and d. And we're going to use the exact same step as before. We're going to find one of the variables. We're going to substitute it into all the other equations. And then instead of having 4 equations, we'll have 3 equations with only 3 variables. And then we'll solve that. All right. what variable is solved for? And it's really nicely solved for. Here we have d is 4. So I can plug in d is 4 here, d is 4 here, and d is 4 here. And then I won't have any d's left over. Negative a plus b minus c, d is 4, so plus 4 equals 9. This one, negative 27a plus 9b minus 3c, d is 4, so plus 4 equals negative 5. In this equation, I'm also going to put in d equals 4. 8a plus 4b plus 2c plus 4 equals 0. Now, I need to simplify this by combining any like terms. There's no, the 4 in each one of them can be moved to the other side. And so I hope we see we can just subtract 4 in each equation to simplify. And we get negative a plus b minus c equals 5. Negative 27a plus 9b minus 3c equals negative 9. And this last one is 8a plus 4b plus 2c equals negative 4. All right, now I have 3 equations without any d's in them, right? This is 3 equations with 3 variables. But I don't have any variable solved for. Sometimes this happens where you don't have a variable solved for. And so what you need to do is you need to take one of the equations where it looks easy to solve for one. I look for just like a blank variable, like just a b, just an a, just a c. These are all a little tricky to solve for because you'd have to end up dividing to get it by itself. But I noticed that like here, b is kind of just by itself. I could solve for, I could solve for any variable, like the c here and here wouldn't be that hard to solve for. The c or the a here wouldn't be that hard to solve for, but b is particularly easy because it's just b by itself. And if I move everything else to the other side, I can solve for b, find out what b is equal to. So I add a to both sides, and I add c to both sides. And now what this one will say is b equals a plus c plus 5. And so by getting b by itself, I have now found what b is equal to, and I can plug that into the other equations, right? b is going to be a plus c plus 5. So let's see how that looks. So I'm going to call this equation 1 and this equation 2. Equation 1, I'm going to write down here. It says negative 27a plus 9b, but instead of b, I'm going to write what? I'm going to write a plus c plus 5. And because it's not just a single thing, because it's a trinomial, there are 3 things adding together, I need to put this in parentheses, a plus c plus 5, so that the 9 multiplies times all of what b was. b is a trinomial, so 9b means 9 times b. It needs to be 9 times all of b. I need to make sure to put that in parentheses. And this second equation, 8a plus 4b, so it's 4 times b is a plus c plus 5. Oops, I don't know where I got minus 3c plus 2c equals negative 4. And now we have 2 equations with just a's and c's. There's no d's, there's no b's. Each time you substitute one of the variables into all the other equations, you end up with 1 fewer equation with 1 fewer variable. And after we do the simplifying, it'll look just like a nice Algebra 1 level equation. Hopefully we can see that the 9 will distribute, give 9a, 9c, and 9 times 5 is 45. And so let's see, what can I combine? Negative 27a plus 9a's is negative 18a's. Those are my like terms. 9c's minus 3c's is 6c's. And 45 doesn't combine with anything on this side, but I can move it to the other side by subtracting 45. So I'm going to go ahead and do that. I'm going to subtract 45. Oops, 45. Get equals negative 54. You might have done this in 2 separate steps. Like if you multiplied all this out and then combined terms, great. I mean, you might have even used 3 steps, that's fine. Simplify this one on your own and get it with a's, c's, and then equals a variable. That's how, or equals a constant. That's how I want it written. Something a, something c, something variable. Go ahead and simplify this on your own. And I hope we noticed that the first thing we would do is distribute. So 8a, here, since I'm going a little bit more slowly, if you had trouble on this, I will write out the steps. 4 times a is 4a, 4 times c is 4c, 4 times 5 is 20. And so I've distributed. Now I'm going to combine my like terms. 8a plus 4a is 12a. 4c's plus 2c's is 6c's. And we can move the 20 to the other side, which is how I asked you to put it. Equals negative 24. So 12a plus 6c equals negative 24. I don't have a variable solved for. It looks kind of ugly to solve for it. I don't have anything I can eliminate yet, but I noticed the 6 c's line up. If I added it together right now, it would add up to 12 c's, but I want it to add up to 0. So I'm going to multiply this top equation by negative 1. I guess the same, you could do this, accomplish the same thing by just subtracting the equations, but I find subtracting negatives could sometimes be a little confusing. I multiplied this top equation by negative 1, and now I have the c's ready to eliminate. 6c and negative 6c, when I add them together, will add up to be 0. So you're always looking for like a 0 pair to eliminate when you just have two equations. 12a plus 18a is 30a. 6c plus negative 6c is 0. Negative 24 plus 54 is 30. 30a equals 30, so we can divide by 30 on each side, or just look and say 30 times what equals 30? A is 1. So a is 1, that's part of the solution. Now I need to plug back in. Here's an equation with just a's and c's. So I'm going to plug in a equals 1 right here. And when I do that, I will get 12 times 1 plus 6c equals negative 24. Oh, I ran out of room here, guys. That's so awful. 12 plus 6c equals negative 24. And I need to move, this is just a one variable equation. We just need to get c by itself. So we subtract 12 on both sides. Negative 36, and we divide by 6. C is negative 6. That's part of our solution too. We need all the variables. Now we need to go back and find what b is equal to. I want to find an easy equation where I can plug in a and c to find b. And back up here, this substitution step is often going to be a really nice candidate. A, we found was 1 down here. C, we found was negative 6. And so when we add them, when we plug it in, we will get b equals 1 minus 6 plus 5. 1 minus 6 is negative 5. Negative 5 plus 5 is 0. So b equals 0. And we need what d is. And look, right back at the very beginning, we actually had the d equaled 4. So a equals 1, b equals 0, c equals negative 6, and d equals 4. That is the solution to this equation. One more thing I want to note is that when a lot of times systems of equations have to do with word problems. I believe in this one, it was asking you, in this case, like x was the smallest. Oh no, did this run out of, hold on. My phone was telling me I had low batteries. It was telling us x was the smallest angle, y was the middle angle, and z was the large angle of the triangle. That's what these variables represented in this problem. And so oftentimes at the end of a word problem, once we've solved for the variables, we want to write a sentence saying like the x was the smallest angle. So the smallest angle measured, this would be a nice geometry way of saying it, 25 degrees. The middle angle measured 53 degrees, because that's what y was equal to. And the largest angle, which was z, the large angle, measured 102 degrees. Remember that for a lot of people, one of the major reasons we use math is to be able to like solve real world problems, and we want to be able to communicate that. In this one, these were the coefficients of a cubic equation. And so the equation was y equals ax cubed plus bx squared plus cx plus d, and we were trying to figure out what equation matched some certain points. And we found that a was 1, b was 0, c was negative 6, and d was 4. And so the equation that goes through those points is y equals, instead of ax cubed, we're going to put 1x cubed. And we usually don't write 1 in front of x because 1 times x cubed is x cubed, plus 0x squared. So we're not going to write any x squareds because 0x squared is 0. C is negative 6, so minus 6x plus 4. This is the equation of the cubic that went through the points. Let me see if I can figure it out from just like looking at this. It must have gone through the points -1, 9, -3, -5, 2, 0, and 0, 4. So this is the cubic equation that goes through those 4 points. All right, that's it, guys. This takes practice, and it is slow at first. When you first start solving these, they take a while, and then they get faster and faster and faster. Again, what's our big idea? We're going to take one variable that we know and substitute into all the other equations, because now we will have one fewer variable and one fewer equation. We'll always simplify to make it easier, and then we just solve a slightly simpler system. And then we always plug back in the end to find all the other variables. All right, guys, that is it for this lesson. I hope you have a good rest of your day. This takes practice. Make sure you get some practice on this.